which are the instruments which are used to measure the displacement, acceleration, or the amplitude of a so-called vibrating body. Why are the seismometers used? What are the two kinds of transducers used in the vibration measuring instruments? What is the brief classification between those two kinds of transducers? What is a seismometer? What does an accelerometer in fact really measure? What is the so-called functionality of vibrometer? And where exactly is tachometer used? Now guys, if you are having the same questions, or rather are having the same so-called doubts and stuff, guys, then what you have done, guys, is simply the best ever course of action which you have undertaken, guys, by coming to this so-called channel, guys. Hello and welcome back to my channel. I'm your aspiring gynecologist and aerospace engineer, Master Chintamani. So guys, here in our today's episode on our channel, guys, I'll be dealing with a lot of current trends, guys, in the world of aerospace engineering, and about the syllabus, and about the tutorials of the graduate aptitude test in engineering, and even about the finite element analysis, even about the town planning, even about lots of updates, guys, which you might want to receive about the uh, space satellite image processing, which I'm simply going to make, guys, in a few moments, about the geothermal engineering, even about the railway engineering, even about the town planning, about historiography of Chhatrapati Shivaji Maharaj, and even about gynecology, especially, guys, about that prolactin hormone. So guys, okay, let us basically, before digressing, guys, continue to our today's topic. So guys, in our today's topic, guys, we gotta learn, guys, as to what are these so-called instruments, guys, which are basically used in the world of vibrational theory and aero-elasticity, the VTA, or which are these so-called electronic equipments, guys, which are basically used, guys, in order to basically perform really accurate calculations, guys, of the calculations of that so-called vibrating potential, guys, vibrating potential in an instrument, or vibrating potential in a string, guys, In order to know more about it, guys, please do subscribe to our channel in case you have not done so. And please do watch our all in videos, guys, onto the same topics, guys, of the aero-elasticity and vibration theory. Okay, so guys, what we're gonna deal with today is, guys, that basically, there seem to be two different kind of transducers, guys, and while we're gonna deal with seismometers, and guys, those two different kinds of transducers, guys, and while we're gonna study about the vibration measuring instruments, guys, seems to be the aseismic instrument, or rather the seismic instrument. So guys, the seismic and the aseismic, guys, these seem to be two sort of broader classifications, guys. And what we learn about the seismometer, and even about the vibrometer, and even the accelerometer. Now, guys, what is the core functionality, or rather the instrumentality of that so-called accelerometer, guys? Is that it basically can measure the acceleration potential, or rather the motion of acceleration, guys, in a so-called system, or rather in a so-called element or eventuality, guys. Then that thing is basically taglined as vibrometer. And guys, the instruments which basically determine the displacement, the amplitude, even the resonance, and even the so-called period, guys, of a so-called instrument, guys, are the instruments which are even capable enough, guys, to determine the rate of vibration, guys. So which is absolutely essential, guys, to study this so-called theory of aerospace elasticity, and even the theory of vibrations. So guys, these all were the so-called potential equipments, which I basically outlined myself, guys, such as the tachometers, seismometers, transducers, even the vibrometers, and even the accelerometers, guys, all of these, which come under that so-called classification of the instruments, which are used to measure the vibration, guys, in the aero-elasticity approach, or rather the approach of the vibrational analysis. Now, guys, seismometers, guys, are basically the so-called instruments, guys, which happen to have the same principle of operability, or same operational characteristics, guys, which are shared by even the vibrometers. So you can very well say, guys, that the operational parameters, or rather the characteristic attributations, guys, of that seismometer and even the vibrometer, guys, and what happens to, fall in synchronization, guys, with each other. And that so-called synchronous, which is basically, present, guys, between the seismometer and the vibrometer, guys, and what happens to basically, make those both instruments, guys, equivalent to each other. So, which means, guys, that the core functionality, or rather the instrumentality, which they basically uh, possess, guys, is also equal. So, which is why seismometer is the same as vibrometer. And guys, which is why, guys, and while we get to study about the seismometer and vibrometer, what we got to learn about is, guys, as to, what are the two different types of transducers, which are transducers, rather the orientation of that transducer, which is basically taken into consideration while we get to study about the seismometric orientation. And obviously, guys, there have to be, two fundamental classification, guys, and while it comes about the tachometers, guys, which are in fact, another really potentially capable vibration measuring instruments, guys. So, which happen to go by the Fullerton tachometer and the From tachometer, guys. Now, these two are the tachometers, guys, which are widely recognized, guys, by the standards of the industries, and or rather, by the standardization or industrial standardization, guys, and which is why these so-called instruments, guys, are used widely, for that so-called purpose of measuring that seismometric coefficient or seismometric potential, or rather, measuring the amplitude, the displacement, the variation, or even the resonance, guys, present in that so-called equipment. So, guys, what resonance, guys, basically means is, guys, resonance is basically a stage, guys, where the excitation energy, guys, happens to fall in a state of equivalence, guys, with the energy of the natural frequency. So, guys, when natural frequency, happens to be in a state of equivalence, guys, with the excitation energy, guys, then it is basically known as the theory of resonance. So, guys, that is what resonance, resonance defines, guys. And even, while we get to deal with the resonating chambers and stuff, whatsoever, we study in the vibrational analytics and stuff, guys, the so-called conceptualization, which I just outlined right now, guys, happens to be absolutely preponderant, guys, to analyze, or rather even introspect. And which is why, guys, what I wanted to say was, guys, that basically resonance, seems to be that so-called fundamental principle, or rather that fundamental property, guys, which is basically responsible for the functionality of that so-called vibrometer, guys, which basically measures the degree, or measures the coefficient, or rather the value, or rather the gradient of displacement, gradient of acceleration, gradient of the resonance, or rather the gradient of the so-called natural frequency, guys, in a system. So, which is basically known as that. And obviously, guys, and while we gotta look up once again to the industrial standardizations, guys, and there seem to be lots of equipments, guys, which are basically used nowadays, guys, for the purpose of measuring the vibrational energy present in so-called equipment. And those all equipments, guys, or rather those all instruments, guys, are taglined, guys, as tagline based on their seismometric orientation, guys, now which seems to be aseismic, or rather seismic. And as I've already told you, guys, that the From tachometer and even the Fullerton tachometer, guys, there seem to be two different kinds of tachometers, which are in fact used in the industrial standards, guys, and while it comes about the analytics of the elasticity, guys, and the vibrational analytics, guys, about it. So, guys, that was about the vibration measuring instruments. So, guys, in order to basically know more about it, guys, please do sign up for our channel. And, guys, in case if you have not still subscribed to our channel, guys, please do that, guys, and In case if you like my content, please do please do click onto that bell icon, guys, such as you never really miss any updates out of it, guys, and where I'm basically gonna share the infographical information, guys, which I'm gonna disseminate, guys, from my end, guys, about the theory of Aero-Elasticity, guys, and about the vibrational measuring instruments, guys, which are basically used for the purpose of measurement of the displacement, measure of the displacement, or rather the measure of the amplitude and a measure of the variation, or even the measure of the resonance, guys. So as I've told you, guys, transducers, signal transducers, seem to be of two different kinds, guys, and tachometers, guys, are basically subclassified, guys, by their further categorization, which is known as the from tachometer and even the so-called Fullerton tachometer. So guys, that was it for today. And in case if you have not watched our previous content, please do revisit to our olden videos, and you will obviously find the link in the description below. See you. Bye.